everybody, this is Miss Bufford, and in this video we're going to talk about accuracy and precision. Your learning goals here are to be able to explain and give examples that illustrate the difference between accuracy and precision. So the first thing that we're going to talk about is what exactly accuracy and precision are and what the difference between them is. So accuracy is really talking more about the correctness of something, or how close a measurement comes to the true or actual value. And the formal definition here is the degree to which the result of a measurement, calculation, or specification conforms to the correct value or to a standard. And precision is talking about reproducibility. So how easily can you reproduce a measurement or reproduce something and get the same result for a calculation? And there's a couple definitions that we're going to talk about. The first one for precision is the quality of being exact, the ability of a measurement, calculation, or specification to be reproduced. And the second definition of precision refers to the smallest division on a measuring device. So how many place values is a measuring device capable of reporting? The more digits a measurement has, the more precise it will be. All right, so let's talk really quick again a little bit more about accuracy and precision, and this kind of gives you a visualization of the differences between those two things. So we're looking first at this first target right here, target number 1, and we can see that all the little dots on this target they're kind of spread out up in this upper quadrant of the target, but they're not really centered over the middle. They're kind of off to the side, and they're really spread out. So what we can say about this target is that it's neither accurate or precise. So no accuracy here. It's not hitting, or the average hit on the target is not really hitting around the center. It's hitting up off to the side. And again, it's not precise because we're not really hitting in the same area of the target. Our hits are kind of spread out. All right, but if we're looking here at target 2, our hits are still spread out, but they're more centered over the center of that target. So if we're talking about accuracy in general, if we're taking all of these hits into consideration, then we could say that that's accurate, because on average, we were around the center of that target, but they're still really spread out, so it's not precise. So for target number 2, it's just accurate, not precise. For target number 3, we can see that our hits are starting to get closer together. We're getting better and better at hitting that same area on the target. But in this case, our hits are not anywhere near the center of the target. They're off to the side again. So we can call this data set, or these dots here, precise but not accurate. So that's target 3. And then target 4 is described as being both precise and accurate because we have all of the hits hitting around the center of that target. If those were data points and we took the average of them, it would be the center of that target. And then all of our hits are starting to get closer and closer together. So these are more precise hits, and so both precise and accurate for that target. All right, so now let's take a look at some measurements and talk about accuracy and precision. So here I have 2 different scales. I have 100 gram standard on both scales. We'll just say for the sake of this explanation that we're using the same 100 gram standard for both scales. So we know it's exactly 100 grams and it's the same one. This first scale would be considered accurate because we're weighing 100 gram standard and it's reading 100 grams. So we could say that that's accurate. As far as accuracy goes for the second scale, though, we would be able to say that's not accurate because we've got that 100 gram standard up there and it's reading 98.89. So that would be not accurate. But think about this for a second. Can we say anything about precision with these measurements here? And I'm going to say no, we can't, because precision is all about reproducibility. If we wanted some data that would allow us to see how precise these scales would be, then we would, take this 100-gram standard off and then put it back on, and then take it off and then put it back on, and record the measurement every time. And if every time we got 100 grams and 100 grams and 100 grams, then we could say that was precise. But if we got, for this one over here, let's say we got 100 grams the first time we measured it, then we got 98.89 grams, then maybe got 105.00 grams. This would not be a very precise scale. Okay, so we can only say something about precision if we have more than one measurement to look at. And as long as those measurements are close together or identical, then we can say that's a precision. We can say that that's got high precision. And if they're not, if they're kind of all over the place, then that's low precision. So now let's take a look at some different measurements. Here we're measuring some volume, and we're trying to measure a total of 100 microliters, but we're doing it in small increments of 20 microliters each. And for this first set of tubes, these are our first 5 measurements in order to try to get 100 microliters. I've got just below 20 microliters, just above 20 microliters, right at 20 microliters, then above and below again. And if I were to add all these up, I do in fact end up with 100 microliters, but my measurements are kind of all over the place. So as far as accuracy goes, I got what I was aiming to get. I have my 100 microliters, but I did not measure very precisely. So my measurements are kind of all over the place. So this first row would be considered accurate, but not precise. Right? So now let's take a look at the second row. So on the second row, I've got measurements that are just under 20 microliters. So if I were to add those up, I'm not going to end up with a total of 100 microliters. I'm going to end up with less. So as far as being accurate, these are not accurate. But if we take a look at the consistency of this measurement, I got the same exact amount of liquid, or same volume of liquid in every single one of those tubes. So I can say that although my measurements were very precise, they were not accurate. Right, so precise but not accurate. And then for this third row of tubes down here, you'll see that I've got 20 microliters perfectly in each one of these tubes. And if I were to add up 20 microliters 5 times, I end up with 100 microliters. So this set of tubes right here is both accurate and precise. Okay. So now let's just take a look at a data table of some data that some students collected when they were doing a lab. And in this lab, students were asked to measure the density of an unknown material so that they could use that information to identify the material. The actual density of this material was 8.96 grams per milliliter. And our job here is to just comment on the accuracy and precision of each student's data. So we're going to look over here at this data table. You see that there are 3 different measurements that each student took, and then they calculated the average density. So when we're looking to say something about accuracy, we really want to look at this average value down here, because that's going to tell us how close all of our measurements averaged out to be to the actual value. And so with student number 1, as far as accuracy goes, they came close, but it's not quite this. It's not 8.96. It's just a little bit lower. So not accurate for here. Student number 2, accuracy-wise, was a little bit high, so not accurate there. But student number 3, got that calculation right on. That all their measurements seem to be right on. So as far as accuracy goes, student number 3 was accurate. So accurate, not accurate, not accurate. All right, so now let's say something about precision. Student number 1, if we take a look at their measurements, they're kind of all over the place. Here we've got something less than what we expected, and then we have 2 more values more than what we expected, and they're considerably more, so we're going to say also not precise. all right? Because those measurements, they're not close enough to be considered precise. But if we take a look at student number 2, student number 2 had 9.01, 9.02, 9.00. Those measurements are close enough for us to consider them precise. So we could say these are precise. And then student number 3, their measurements, 8.97, 8.96, 8.95. Again, those are really close to each other, so we can consider that precise. So student 1, not accurate, not precise. Student number 2, not accurate but precise. And student number 3 is both accurate and precise. All right, hopefully this video was helpful. If you have any questions, don't hesitate to send me an email or message me through It's Learning. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry help.